Hi, this is Naresh Tukani. I am working as a technical leader for Criterion Networks Incorporation. This video is to demonstrate one of the popular use case of SDN in the service provider migration area called the BGP free provider edge use case for the MPLS layer 3 VPN networks. The CN Labs, what we see here is one of the division of Criterion Networks and which is one of the international testing lab facility for open flow conformance in the world. What we'll try to do as part of the video is that we'll try to initially spend some couple of minutes on understanding the legacy topology architecture, followed by how one can go about into the SDN migration architecture. So in the legacy topology, we have a standard representation of the customer edge and the provider edge and the provider routers topology, where you have the customer edge routers on the either end. The provider edge routers, which is at the edge of the MPLS backbone, are represented here, which are connected by a provider route P router in the core of the MPLS backbone. We also have a route reflector in place, which helps to sort of remove the mesh connections among the provider edge routers across the MPLS backbone. In terms of the connections that we have with respect to the devices, we have the eBGP connection between the CE1 and the PE1, and similarly between CE2 and the PE2. We are running the iBGP as an OSPF with respect to the MPLS backbone in order to share the prefixes among PE1, PE2 and P and the route reflector. We are running an LTP protocol across the MPLS backbone. We are running the MP-BGP connection between the PE1 router and the route reflector, and similarly between route reflector and the PE2 in order to exchange the prefixes and related VPN information. So in the legacy topology, which we also call traditional topology or traditional network design, we have the control plane and the data plane intact within every network element, where the control processing takes place in all the elements, and the data plane, if we initiate a ping between CE2 and the CE1, the data goes from CE2 to PE2, which in turn forwards it to the P router, which in turn forwards it to the PE1 router based on the MPLS labels, and PE1 router takes off the MPLS label and forward it to the CE1. So this is a typical data flow between CE2 to CE1. Now let us try to see how one can migrate into an SDN based architecture. There are a couple of ways in which one can move into an SDN architecture. We will use the following procedure. We try to replace the provider edge 2 router, which is here in this figure, in terms of an open flow device in the SDN migration topology. So, and the open vSwitch or OVS is one soft switch implementation of that. So we are using that as a purpose of the demo. In order to program an open vSwitch or an open flow device, we require an open flow controller. So we are using the OpenJLite Helium version in order to program the respective flows onto the open vSwitch. In terms of the control plane processing on behalf of the open vSwitch, we have a route controller which is placed here. It can be either virtual or physical. It happened to be physical in our case, which does all the respective programming or processing of the control plane packets. So when in the traditional SDN architecture, where you have the control plane and the data plane decoupled, the data plane is still, or the forwarding is still happening in this switch. The control plane processing for this switch is taken out into the form of a route controller. And OpenJLite is used to program the flows based on the control plane information that is learned. In other words, the provider edge, whatever the OSPF, LLDP packets, whatever it is sending from the route reflector and the CE2, which are being sent to the PE2 in the earlier case as well, are now being redirected into the route controller, which does the packet processing for us. Now, when we initiate, and what the application layer, what it is doing at this point is that whatever the route control information and the respective MPLS based flows are being grabbed by the application and being sent across the REST API calls into the OpenJLite controller, which in turn is going and programming the open vSwitch for the respective network and the MPLS based information. Now, if we initiate a data ping from the CE2 to CE1, the packets go from CE2 to PE2. Now here, based on the MPLS information that has been programmed from the OpenJLite, it automatically attaches those related as respective MPLS labels, and the packet gets forwarded to the P router, which eventually goes to the PE1, which removes the MPLS label and sends it to the CE1. So what happens is that the data plane is still intact, very much in the same like the legacy topology, but however the control element of one of the element is taken out of into a different plane, and we are using the OpenJLite in order to grab that information using an application in order to program the open vSwitch. So this is how one can migrate from legacy topology into an SDN based architecture in the service provider networks. And we will see a short demo in the SDN migration topology by adding and removing few networks now. In this video, we will see how the packet forwarding happens for all the networks that are being added and deleted on the customer edge networks. So we have the CE1 here and the CE2 here, the terminal, where it is trying to advertise the 4.4.4.4 network into the system. We have the Pro1 here and the PE2, which has been implemented within Open vSwitch in the form of Open vSwitch. We have the Helium, which is an open daylight controller, which is getting a REST call from the application in order to program the MPLS based flows. And application is running here, which is getting the required information from the RC. So what we'll try to do as a part of demo is that the CE1, which is emulated as a Quagga engine here, we will see that there is no initial network of 4.4.4.4. So when we try to initiate a ping, the packet flow doesn't happen. Now we'll try to go into the CE2 and we'll try to start advertising the network 4.4.4 into the system. Once we start advertising into the system, we can see that the application which is looking for any network changes in the system has seen that there is a network that has been added 4.4.4.4 and added 4007 as an MPLS label to that. And we can also see from the Open vSwitch for any flow that has been added for 4007 is that a new MPLS label has been added to the 4007. And now what we should see from CE1 is that automatically the ping has been started for this network, which was not happening earlier. What we'll try to do now is that we'll try to go again delete the network in the 4.4.4 network. And immediately we should see on the CE1 that the packet forwarding has stopped. We have to see on the application that it has detected that there is a change in the network and started deleting the flows. And now when we go to the Open vSwitch, this was the flow earlier, it was responsible for packet forwarding, and now when we try to give the same command, we see that there are no more flows that are with the 4007. So in this way, what are the changes that are happening in the network, the prefixes being added and deleted are instantly being analyzed by the application and seamlessly writing on with the help of Open Daylight controller onto the Open vSwitch in the SDN migration topology. Thanks for watching the video. Please send us your valuable comments in terms of moving from legacy architecture into the SDN based architecture, and we appreciate your inputs.